use the term economic and social networks very broadly to mean any network or system in which the human element, both individual and autonomous decision making, as well as its interaction with the underlying technological infrastructure, is crucial in the operation of these networks. So a prominent example is technological networks, communication networks, or the power grid, where the goal is to deliver services to the end users. And in these systems, the technological issues are very tightly knit with the economic and social aspects. For instance, if you think about the internet, it's not just a technological network, but rather a commercial enterprise, worldwide enterprise, which involves many different entities with different economic motives and serve many millions of end users with heterogeneous requirements. Similarly, if you think about the power network, it's not just a technological network which delivers electricity to homes, but you can easily view it as an economic network that constrains the flow of a good, electricity, from its competing producers to utility maximizing consumers. So network structure also, or the networks emerge in economic and social interactions. If you think about our social relations now, they're organized around networks of friends and colleagues which determine our information, influence our opinions, shape our all kinds of political attitudes, business decisions. And similarly, economic and financial systems also look much more like networks rather than anonymous marketplaces. So developing models that actually incorporate the individual decision making and its interaction with the underlying network structure is very crucial in developing efficient optimization algorithms and designing incentives for ensuring more efficient operation of these systems. I do have work in communications networks also, but my examples are drawn from two recent projects in my group. The first one is in traffic networks. As we all know, congestion is a major issue in many big cities in US and all around the world. And on the academic side, there's a lot of research and interest in developing and analyzing various approaches for easing congestion, ranging from designing tolls, penalties or restrictions, as well as more recently incentive or reward schemes for temporally shifting traffic to reduce the peak congestion levels at rush hour. And thanks to GPS-based devices, Waze, Google Map, another now interesting strategy for controlling flows is providing information. So providing information to commuters about a new route that has less congestion that they didn't know about, and with the goal of reducing travel times, at least to their own users. But if you think about these traffic information systems, their impact on the overall congestion or social efficiency is not well understood. So in order to tackle the impact of such incentive mechanisms or such interventions and see what its implications, social implications are, my group basically develops game theoretic models that describes how commuters make route choices for given particular incentive or information structures, so that understanding this is the first step to designing optimization algorithms or optimizing over these controls to improve the operation of the system in the sense of reducing congestion, reducing total cost in the system. So that's one project that we're excited about. Another important issue that we focus on recently is the issue of cascades and systemic risk in networks. And this is very much motivated by the 2008 financial crisis, as well as the observed local disruptions and how these local disruptions amplify and affect the global supply chain. So basically, systemic risk refers to the problem that small individual shocks to some part of the system, to some entities, propagate to the rest of the network because of interconnection, causing cascaded failures and even ultimately a complete meltdown of the system. So this is a prominent problem, happens in financial systems, power grid, global supply chain, and the research in our group develops models for these different problems in different contexts for understanding which of the connectivity structures or architectures, if you wish, minimize this effect, contain systemic risk, and which of those amplify, leading to more cascaded failures. And having an understanding, such a systematic understanding, allows us also to design static and real-time intervention mechanisms when we have limited budget on how we should use our resources or intervention strategies to contain the damage in the system. So risk and systemic risk are very important questions in many domains. Finance is in particular an important one. And this goes into IDSS, but in IDSS, finance is also a flagship area, and we've actually started exploring connections to firms and regulatory agencies for studying this question together, partnering in studying these risk issues together, using both models as well as available data through these collaborations.